So when we look at the skin, it has several functions that keep us alive and help maintain homeostasis. Protection. Protection is definitely a major one that we immediately think about. The outside or superficial portion of our integumentary system, all epidermis, stratified squamous epithelium, if you watched lesson 2 on tissues, and it helps protect us. Think about all the bacteria and viruses, fungi, etc. that would quickly get into our body if it wasn't for this outside protective layer. So it's one of those first lines of defense in protecting our body from foreign pathogens or invaders. Absorption. It's not just absorption of sunscreen or nicotine with a nicotine patch. One natural absorption that happens every day is when you're outside and the sunlight's hitting you. UV radiation or ultraviolet radiation from the sun is penetrating into the layers of your skin, causing the generation of vitamin D from that UV radiation. And you can absorb other things. There's even slight absorption of water into the layers of your skin. Your skin isn't really waterproof, but it is highly water resistant. So the regulation of how much is absorbed, you can thank your skin for that. Secretion. A lot of products are secreted, the opposite of absorption. So secretion, it's not just sweat, but sweat's a major one. Sweat is mostly water, but there's going to be little particles in the water too. Electrolytes are what you lose when you sweat a lot, and that's why people will, drink energy drinks, full of those electrolytes, or eat a banana to help replace the potassium they may have lost. But yeah, secretion, one way of getting sweat out in terms of regulating your body heat and releasing some waste products through sweat. Speaking of body heat, heat regulation, not just in terms of cooling down our body through sweating, but the opposite, preventing our body from getting too cold. Every time that you get goosebumps or goose pimples, that's because the pores in your skin are stimulated to close and the hairs in those pores stand straight up thanks to muscular action in your dermis. You don't consciously control those muscular contractions, but that's part of keeping heat in when we get those goosebumps. And finally, aesthetics. A lot of people don't think about this, but aesthetics means beauty. And if you find someone attractive, when you look at them, what your eyes are actually seeing is the light reflecting off of their epidermis. That's what we notice when we look at someone, is those epidermal layers, the outer portions of the skin. So if you're attracted to them, thank their skin for that aesthetic quality. This is a lovely diagram from Grey's Anatomy. Not like the TV show, but it's a play on word. That's why that TV show is called that. So the show on TV, Grey, Grey's Anatomy, named after, in a punny way, Gray's Anatomy, Gray, which is a famous anatomical textbook. It'd be used a lot in medical school because so many good diagrams, so much detail in terms of labeling the body parts and describing their functions. So this is a classic look from Gray's Anatomy, the textbook, and you can tell by this particular font is very common in Gray's Anatomy, and this style of drawing. So this is allowing us to look at the different layers of skin. Up here superficially we've got the epidermis. Here you see dermis, very thick layer filled with many layers of skin. And then finally the hypodermis, or the lower levels, the deeper levels, also known as the subcutaneous layer, is down here. And here's a little bundle of fat associated with that. The major layers of the skin, I just mentioned them on the previous slide, but here's a great drawing in terms of where they're actually separated. So first we'll talk about the epidermis. You can see that the epidermis exists from the most superficial portions and the top layers on the very superficial part, stratum corneum, and then down through to the end of this little purple section. So this right here is the deepest part of the epidermis. And you can see how it's kind of wavy. This is called the stratum basale, which I'm going to talk more about on a slide in the future. This is the basement membrane that anchors all of the epidermal cells. And you do have a few different cell types in there. Most of the epidermis is dead, and the parts that aren't actually dead cells, they're nearby blood flow. The blood flow actually comes up to the very superficial portions of the dermis. So just deep to the epidermis, very thick layer, exists right in here. And the actual border between the dermis and hypodermis, or subcutaneous layer, is not well defined. The border between the epidermis and dermis is well defined by this right here, the stratum basale. But you can see that depending on what portion of the skin you're in, the amount of yellow stuff you see in here is going to vary in terms of how deep it is or how superficial it is. So the border between the dermis and hypodermis, not as well defined as the one on top. In the dermis, you've got a lot going on: hair, sweat glands, blood flow, neurons, all kinds of stuff that we'll cover a little bit later in the lesson. And like I said, the subcutaneous layer, also known as the hypodermis, hypo meaning under or below, that's mostly fat bodies and major blood vessels in terms of the veins and arteries that are feeding your skin, the superficial portions of it, with oxygen and nutrients. So we'll start with the epidermis, the most superficial layers of skin. It's not just one layer. People tend to think that the epidermis is just one layer on the outside. No, it tends to be 10 to 30 cells thick. And I wrote epithelial here because if you saw lesson 2 on the different types of tissues, epithelium lines the outside of organs and the innermost cavities of organs where you have a space or tubular passageway. So all of the epidermis is basically composed of stratified squamous epithelium, those stacks of those round sort of plate-like cells from the bottom on up to the top. And depending on where you are in the body, it may be only 10 cells, it may be 30 or even more. Let's take the eyelids, for instance. This is one of the thinnest parts of skin in your entire body. So you would imagine the amount of epidermal cells significantly less than on the palms of your hands or the soles of your feet. You can feel that the skin is thicker here. And if you develop a callus, that's even greater thickening of the skin in response to friction. Whether you're swinging a bat or lifting something, that extra friction that you experience on a daily basis with your hands touching things, with your feet walking, is the reason why you would get some extra epidermal development there. Speaking of epidermal development, the two main kinds of cells that you would see in the epidermis are melanocytes and keratinocytes. So let me start with melanocytes. Melanocytes tend to be scattered in the stratum germinativum layer, the deepest part of the epidermis. Let me draw you what that kind of looks like. And I'll explain what these little finger-like projections are in a bit. So that is a melanocyte. And underneath that, just deep to it, you would see the basement membrane, also known as the stratum basale, which is that well-defined border between the epidermis and the dermis underneath it. So you tend to see melanocytes, these melanin-producing cells, along the deepest parts of your epidermis. So the melanin that's produced, this is that pigment that ends up in your skin, hair, and irises of your eyes that gives color. The more melanin you produce, the darker your skin and hair are going to be. So you've got production of melanin, this pigment molecule, in the melanocytes, and cyte, C-Y-T-E, actually means cell. So melanin producing cell, those melanin deposits end up in these little cellular extensions, finger-like projections of the melanocytes that go up more superficially, and they allow depositing of melanin in cells that are a bit higher up in the epidermal layers. The darker your skin is, the more melanin your melanocytes are producing. And even if you're albino, somebody who has no skin pigment, hair pigment, you're going to be filled with melanocytes. It's natural to have this kind of cell in your epidermis, but their melanocytes are inactive. They do not produce melanin, and that's why they have that pale look. And they are more sensitive to UV radiation and getting skin cancer. So melanin not only provides color to your skin and the hair shafts, but it also is protective in terms of shielding your skin cells from their DNA getting harmed by UV radiation coming at you. Keratinocytes, these produce keratin. So keratin is a protein that's meant to be protective for your skin and also helps your skin in terms of water resistance. So keratinocytes scattered throughout the epidermis The ones at the deeper parts, they're resulting from cell divisions down there, from mitosis. And as the keratinocytes get pushed up farther and farther and farther, they get more dead in a sense because they're getting pushed farther away from blood flow from all the capillaries, the tiny blood vessels of your dermis. So the way that the epidermis actually gets nutrients is through diffusion up into those layers of the epidermis. But the farther away, like when you finally get cells up here at the stratum corneum, up at the very superficial parts, completely dead, and they're just jam-packed with keratin, with this protein that's giving your skin protection and helping to shield it from too much water going in or out. So when I do this, I am brushing off just so many cells, thousands of cells, and thankfully I'm going to produce more skin cells to take the place of the ones that have been brushed off from the top portions. Like I said before, the stratum basale is that layer here that separates the epidermis from the dermis. And from lesson 2, that's actually the basement membrane of this epithelium. Oh, one more thing before I move on. The stratum basale helps form the fingerprints. Interestingly enough, identical twins who have the same DNA from their parents do not have the same fingerprints. They will make different fingerprints if you take them. And the reason why is as their skin is developing in utero while they're in the womb, the way that their early skin gets affected by them moving through the amniotic fluid and rubbing against the inside of the amniotic sac that they're in, that manipulates how this stratum basale is formed in terms of the exact peaks and valleys. So that formation in the womb actually results in fingerprints, and that's why even identical twins have different fingerprints. Now onto the dermis. The dermis is the middle layers of skin, a lot thicker than the epidermis, and this is where you have all kinds of stuff going on anatomically and physiologically from deeper in terms of blood vessels coming up into the skin, neurons coming up in the skin to allow you to sense your environment, and so on. So the middle layers of skin, lots of cells. What you're definitely going to be having in here is blood flow. So here's a little reminder of what we're looking at. And I'm going to explain in a bit what this is. So up here, remember this is the epidermis. Down here, we're talking dermis. And then finally, deep to that, you would see the even lower subcutaneous layer. But blood flow, you're going to have capillaries coming up into this area. And once oxygen is given to all these cells, you get blue blood, and that goes back into thicker veins that are much deeper. Here's an artery, a major artery down here. Smaller artery is a better way to put it. That's feeding the more superficial layers. So here's a smaller branching. This is a capillary. And you're going to have oxygen and nutrients being given to all these cells here. And like I mentioned before, capillaries will go all the way up to the stratum basale, but not protrude actually into the epidermis. That's why if you ever were like cutting vegetables and the knife slipped and you're like, oh, and you expected blood to come out, but it never did, that's because you just severed through these parts of the epidermis. You didn't actually end up cutting through capillaries or blood vessels. Now, of course, if the cut is deep enough, you're going to be cutting through the millions and millions and millions of capillaries that you would find in your integumentary system. So, of course, blood flow into the dermis, very important for feeding the dermis and the superficial layers of the epidermis. So hair. Hair is the next one. We're going to draw a little hair shaft coming out of here. And I'm not going to color in the whole thing, but we'll say it's a dark hair. So the hair shaft is the actual hair that's generated by the hair follicle. So the follicle is this whole thing. That includes the cells that actually help produce a new hair if this hair shaft actually comes out. And the average person loses about 50 hairs per day, mostly from the head. And if you're losing more like 100 or 200 per day, you may be heading towards baldness before someone else, because the rate at which you produce new hairs underneath these hair shafts has a lot to do with genetics and with nutrition, etc. And of course, feeding this follicle, you would definitely have little capillaries coming in and feeding these cells that actually help produce this hair shaft. And it is true that hairs are mostly dead. When we're talking down here at the root, yes, you do have blood flow and those cells are nourished. But as cells get pushed higher up, all these cells at the more apex, the end of this particular hair shaft, are going to be dead, entirely dead cells. The outside of the hair is known as the cortex. The inside is known as the medulla. Those terms are going to come up later on in lessons as well. So yes, follicle, this entire thing, and the hair shaft is the specific hair that's actually produced within the follicle. Glands. The first gland I want to mention actually has a lot to do with hairs. Sebaceous glands. That's what you're looking at here. So this would be made of glandular epithelium, and sebaceous glands help produce and secrete an oily substance that actually helps nourish the hair. If it wasn't for your sebaceous glands, your hairs wouldn't be as healthy. And yes, if you haven't washed your hair in a while, you haven't used shampoo and conditioner, etc., you're going to get a greasy look in your hair because of all that extra sebum that's produced. Sebum, not a lazy sailor. Sebum is what's secreted by sebaceous glands, and this is how you spell it. So sebaceous glands associated with hair follicles and secreting that oily substance onto the hair shaft. Sweat glands. Sweat glands, there's a couple different kinds, eccrine and apocrine. Eccrine, the other nickname you're going to see for eccrine glands is merocrine glands. Interestingly enough, apocrine glands, they're actually another kind of merocrine gland. When they were first discovered, scientists thought they were producing apocrine secretions. Turns out they actually are producing merocrine ones, but since enough was already been written about them and enough studying of them had already been done, they kept the name the same. So if you're wondering what merocrine glands are, that was mentioned in lesson 2 on tissues. So eccrine glands scattered all around the body. Let me show you what these do or what they look like. And just like hair shafts going through the pores on the surface of the skin, sweat glands do as well. And you see this like crazy bundling of the sweat gland material here. So the interesting thing is if you took a single eccrine sweat gland and you unraveled the whole thing, they actually would be pretty long in terms of their length, but it's tightly coiled. And you get a production of sweat in the tubes here, and then the sweat gets secreted when needed, of course. So eccrine glands, mostly associated with heat regulation in terms of getting rid of water, and that's a way to cool down the body. So eccrine glands are going to be found all over the place, especially the palms, the bottoms of the feet, the forehead, the neck, places you tend to sweat when your heart rate goes up and your body heat goes up. So eccrine mostly having to do with regulating your heat level in the body and getting rid of some waste products. Apocrine, a bit different. Structurally they look similar, but apocrine glands tend to be activated more at puberty. And apocrine glands are more associated with the armpits, around the nipples, and the groin region. And so secretions from apocrine glands, yes, it's going to happen when your body heat goes up, but there's more of a correlation with puberty and the implications of that. There's some theories that humans are secreting pheromones through their apocrine glands, and pheromones, if you study the animal kingdom, are those airborne chemicals that attract the sexes to each other. So if you fall in love with someone at first sight, and maybe they're not your normal type that you visually are attracted to, it could be the pheromones from their body that have been sweated out of their body that your brain notices on an unconscious level. Look them up. Pheromones are quite fascinating. And so those are more associated with the apocrine sweat glands. Erector pili muscles. Let me show you that in red because they are muscles. Erector meaning standing it straight up, and pili muscles has to do with the hairs. So here's an erector pili muscle. It's not considered a skeletal muscle because it's not connected to bone and you don't have conscious control over these. So the erector pili muscles associated with the hair shaft, like I mentioned before with your pores closing and the hair standing straight up, it's your erector pili muscles contracting to do that. And that's part of the process of closing a pore and keeping heat inside your body. Speaking of hairs, there are two main kinds of hairs found in the body. There are vellus hairs and terminal hairs. So vellus hairs are those little like kind of peach fuzz hairs that you find all over the body. If I look really close on my forearm, I see these little whitish looking hairs all over the place. Right here on my hand, I see them scattered all over the place. So those vellus hairs are those kind of light ones that we don't notice very much, but they're all over the body. Some places that you wouldn't see them are typically on the palms, the bottoms of the feet, and your eyelids, and on your lips itself. You're not going to typically see vellus hairs. Terminal hairs, those are the darker ones. I mean, even if you're blonde, they tend to be darker than the vellus hairs. And so those tend to be most concentrated on the head. You're going to see them in the armpits, the pubic region, and depending on whether you're male or female and hormone levels, you're going to see them elsewhere, of course, even on the forearm, for instance. So vellus hairs all over the body. Terminal, not quite everywhere on the body, but you do have a lot of them, especially on the head. Speaking of vellus versus terminal, there's a misconception that a chimpanzee or an ape has way more hairs than us. They have close to the same amount because even though at first glance it looks like humans have a lot less hair, if you add up all the vellus hairs and all the terminal hairs, we got a lot too. And the vellus hairs just aren't as visible, but they're scattered all around the body. Our hairs compared to an ape are just not as thick, not as long in general. More about the dermis. So nails. Since we're mammals, these nails came from our mammalian ancestors. So they used to be claws if you go way back when. So here is a top view of a nail. And here's the lunula. So here's a nail, that white part that you would see on a thumb, lunula, named after the fact it looks kind of like a crescent moon. This is located next to the root of the nail, which is actually covered by parts of your skin. So you can't quite see the parts that are helping to make your nails, because there's always mitosis happening down here. That's why you have to keep cutting your nails. The lunula just has some extra shielding of that, so you can't really see the blood flow. That's why it looks white. Whereas the rest of your nail, if you press down on it, you can see that pink look kind of goes away temporarily because I'm kind of squeezing blood out of the little capillaries underneath the nail plate. So the lunula, on the average person, it's not on every finger, at least not visible on every finger. On me, I can see my lunulas on my thumbs, but not on the rest of my digits. Some people, you can't see them at all, and it's rare, but some people have them visible on all their nails. So the nail bed is what the actual nail itself is resting on, and the nail plate is this highly keratinized, hard, super hard part that we know as the nail. So a side view, let me show you the side view here. Just looking like that. The nail bed would actually be that nourishing part that's underneath it. You're going to have blood flow to the nail bed, and the nail plate itself is actually that looking down on it and this. So here is the nail plate itself. Cutaneous receptors is the last major item you're going to see in the dermis. Cutaneous receptors are nerve endings allowing you to notice the stimuli that's coming into contact with your body. So whether it's touch, some of them respond to being touched, pressure changes, even barometric pressure changes in the atmosphere could have an impact. But of course, it's also pressure changes in terms of feeling pressure on you, physical pressure. Humidity, the amount of water vaporized in the air is going to affect certain nerve endings in your dermis. The heat, Of course, the amount of heat that's being experienced is going to correspond to the activation of eccrine sweat glands. Pain, definitely. If you've been cut, you're going to feel that pain, and it's going to be registered in the brain. And chemical changes. Having certain chemicals hit your body can cause an allergic reaction, but even if you don't get an allergic reaction, the cutaneous receptors are going to be responding to that. In addition to these parts of the dermis, you're also going to see a lot of connective tissue scattered throughout the dermis, anchoring these particular tissues and keeping the dermis arranged as it should be. And then the subcutaneous layer. This is the deepest part of the skin, and this particular part right here, you've got mainly connective tissue, and the specific kinds of connective tissue are for fat storage, adipocytes. This literally means cells that store lipids. It's your adipose tissue. And depending on what part of the body you're in, the actual adipose storage will vary. A place like your eyelid, not going to have a significant amount of adipose tissue, but a place like your rear, your posterior, the buttocks, you're going to have a lot more adipose storage in the adipocytes. And so you're specifically storing fats or lipids in these little yellow clumps. Blood flow, that's obvious from here. You can see a vein and an artery, artery and vein, and then you also have lymph vessels. You'll hear more about those in the lymphatic organ system lessons, your immune system. And you're going to have those major arteries much deeper. So even deeper to the subcutaneous layer, major arteries feeding the arm, like the brachial artery and the brachial vein, they're going to branch into tinier arteries that will feed those more superficial layers. And when you watch the blood vessel lessons, you're going to see that veins tend to be more superficial to arteries, and that helps regulate your heat levels in your body. So of course, blood flow and then branching up into these tinier blood vessels is what you would find in the subcutaneous layer. All right, cuts and healing. So cuts happen. Sometimes you get a scar, other times you don't. It depends on how severe the cut is. So there are 4 main steps in terms of healing that cut, preventing you from bleeding out and dying from blood loss, and getting the skin back to as close to normal as possible. So step 1, inflammation. Let me draw a little picture for you. So here's the epidermis, okay, right up in here, and here is the dermis. So because the cut has gone into the dermis, you're gonna get bleeding, definitely, because you've cut into the blood vessels of the dermis. So blood pours in. Look at all the blood. So the first response to getting a cut is, well, of course, blood's going to pour into there, but inflammation happens. The blood vessels that are physically feeding the dermis, they're going to be stimulated to expand. I know that sounds ironic because you got blood coming out. Why would you want them to expand? Well, your body wants to get more white blood cells and other cells that are going to help protect this area and regenerate it. So getting more blood flow to this area through expanded blood vessels is just a part of the inflammatory response associated with your immune system and your cardiovascular system. So you're definitely going to have inflammation occurring, and mast cells are what are going to be stimulating that. Mast cells are a kind of cell of the connective tissue that are going to secrete histamine, which causes the inflammation to occur, and heparin at the right moment, and that's to thin your blood and make it not clot. But you are definitely going to be clotting this area because, like I said, you don't want to be bleeding out continuously. So after a few hours, you finally get migration. And of course, it depends. The exact amount of time depends on how significant this cut is in terms of its size and the width, etc. So that was inflammation. Migration, well, what is migrating? You're definitely going to get certain fibroblasts migrating to this area. So let me draw little fibroblasts. And I'm going to erase some of this, and you'll see why. So as your blood vessels form little clots, little plugs, the amount of blood coming into this area is going to be reduced. Slightly less blood will be coming out through the open wound, and you're going to get little fibroblasts secreting connective tissue fibers to help rebind the areas that have been separated. So what's migrating here is definitely fibroblasts. They're coming into that area, helping out here, and you're also going to get phagocytosis happening. Phagocytosis means cellular eating. And what's doing the cellular eating? They're called macrophages. So macrophages are even bigger cells. I'm drawing them right here. These larger cells are going to be eating up cellular debris, the damaged cells from this particular laceration or cut, and the little bits of blood cells that they come across that have been leaked into this space. So as those clean up the debris through swallowing up that stuff, that's what cellular eating means, you're going to get also these fibroblasts secreting fibers and helping to reconnect this area. Flash forward a few days, we're going to get what's called proliferation. And I almost forgot, you're going to get a scab, usually after a few hours. So here's that scab. That's basically part of the clotting blood exposed to the air, so it dries out, and it's a nice shield for what's going on under this. You know that if you pick off a scab prematurely, it's a little bit harder for your body to heal it, and you're more likely to get a scar if you keep picking out a scab. But you're going to get what's called proliferation next. So there's slightly less of this clotted blood here, but what you're going to get is continued fibroblast production, getting continued connecting together of these damaged parts of the skin by secreting those collagen fibers, etc. And you're going to get definitely increased fibroblasts, and the amount of phagocytosis is going to be reduced significantly because you've already cleaned up most of that debris at this point. And then maturation. So at this point, the scab is gone. Hopefully it's not a scar, but oftentimes when it first heals, there'll be a little that what's remaining after the scab falls off, it sometimes is a little bit indented, but as you get continued maturation of this newly formed area of skin, new connective tissue, etc., sometimes it will get pushed up a little bit more as time goes on, so the scar is a little bit less visible as time goes on. Some people form what are called keloids, which are elevated scars, even with really tiny cuts, and we think there are genetic factors associated with that. But these are the four main ways that you heal a cut and prevent yourself from bleeding out. Burns. This is another major issue with the skin. They're not just caused by fire or heat. That is one of the main ways that burns are caused, but chemical burns can also happen. Really strong acids hitting your skin, really strong bases, alkaline substances, can definitely harm your skin. Electricity burns, getting shocked by electricity, getting struck by lightning, that's going to cause a burn. And it's not just the skin, it will definitely burn your internal organs and could potentially be fatal. Friction, whether it's a rug burn or a blister has developed from like lifting weights without gloves or swinging a bat, those are friction burns. I actually have a friction burn on the bottom of one of my feet because the last few days I've been walking around in sandals, and yesterday I walked around probably about 10 miles in sandals and was walking quite briskly. So when I was done, I had a blister on the bottom of my foot because so much rubbing and that inadequate support and cushioning on my foot caused a second-degree burn in a sense, and I'll tell you more about that momentarily. First-degree burns, and really we could say there's 4 degrees of burns. First-degree burn is primarily affecting the epidermis. Most classic one would be a sunburn. Those heal quicker because if you're just burning and harming the epidermal cells, they're very easily replaced. You're constantly shedding them and you're not damaging any parts of the dermis. So typically a sunburn goes away within a few days, maybe a week. It really depends on the severity of the sunburn. But also you could get a minor heat burn, not from the sun, or a minor friction burn that would be considered first degree, as long as it doesn't penetrate into the dermis. Next up, second degree burn is harming not only epidermal cells, but damaging dermal cells. Could be a really severe sunburn, could be from getting hot water spilled on you, could be a friction burn. And oftentimes it's not just redness associated with a second degree burn, blisters, kind of a slightly waxy look can also appear. But blisters are very common because think about how many fluid-filled little chambers there are in the dermis, not only blood vessels, but sweat glands, etc. So when those tissues get damaged, pooling a fluid in the form of a blister, and those can take longer to heal. Third degree burn can be more fatal depending on how extensive the third degree burns are. That's getting down into the hypodermis. So getting burned with fire, getting such a bad chemical burn that it damages epidermis, dermis, all the way down. You're going to require skin grafts typically, because if you've damaged all of the dermis, that's where these major tissues are housed, and you can't easily get these back once you've damaged them. So damage down into the hypodermis is permanent, but skin grafts from either your own body, they'll take skin from a certain part of your body, put it on there, or skin from a cadaver, a dead body, and give you drugs to kind of calm down your immune system so you can accept that skin from the cadaver if it's from another body. And the danger with third degree burns is if you don't get a skin graft quickly, the chances of infection are very high. Because think about all the protective parts you've lost because of that third degree burn. Somebody who has third degree burns over their body, very susceptible to infection. And fourth degree burns, I didn't even know those existed until about a year ago. That is a term not used often because you rarely see them, but that's damaging even down through all of the hypodermis, down to the muscle or bone. And those are incredibly fatal if they're over a lot of the body. So in terms of burns, with communicating quickly and adequately between emergency people, paramedics, EMTs, and hospital staff, where you're going to find nurses, doctors, surgeons, there's this rule of nines that's kind of interesting in terms of approximating how widely distributed the burn is on the surface of the skin. So someone kind of figured out the percentages of skin covering your body relative to the areas it's on. And they came up with the rule of nines. So let's say somebody burns all of an arm, their entire arm is burned, second degree or third degree. All of this is 9% approximately, and that's the entire thing. So both arms together, if you burn just the arms in their entirety, you've burned 18% of your skin effectively. Burning from here down, 4.5%, or you could approximate 4 or 5. But each arm, about 9% of your skin. The legs, if you think about it, your legs have about twice as much skin on average. They're longer and typically they're thicker. So a leg is actually twice as much skin as an arm. 18%. So if you burn just half of a leg, once again, that's 9%. If you burn the bottom half of both legs, 18%. Burn all of both legs, 18 times 2, 36%. Your torso as a whole, the chest and parts of your pelvic area, about 36%. So burning all of the front of your chest, just the ventral portion or anterior portion of your chest, that's going to be 18%. Burning just the back, 18%. And the whole thing would, yes, be 36%. The entire head, all of your head is going to be 9% approximately. So if they burn all of their face, you could say 4 or 5%. Perineum. The perineum, This is a part of skin associated with the groin area. It's only 1%, not much of your skin, but that's the only exception to this rule of nines in terms of multiples of 9. If you add up all of these, 9 times 2, 18 times 2, 36 plus 9 plus 1, you get, surprise, surprise, 100% of your skin. And this is a way for an EMT or paramedic to quickly communicate with the ER that they're taking this person to for surgery, perhaps, and skin grafts. Enables them to like quickly be prepared for how severe this is. Because if I were to radio and say, we have a person with 9% of their body burned with second-degree burns, that's not as severe. But if we say third-degree burns on 45% of their body, that's much more severe. So that's how the rule of nines is applied. Now for some skin conditions and disorders. We already mentioned scars a little bit earlier on and how cuts heal, but scars, this one here is actually called a keloid. This is an elevated scar, not very common, but some people get them. Wherever they get a cut, there's an elevated scar from additional production. It's kind of like overproduction of your fibers and skin cells in response to this cut. But the average scar is just a remnant of where you had a cut. And depending on how wide it is, how deep it is, you're more likely to get a permanent mark that your skin couldn't quite repair to look how it was before. And like I said, the thickness of it has a lot to do with it, because a thick cut and deep cut, they say you need stitches. The reason why they tell you need stitches is by binding together where you had that little divot or cut, it's just helping your skin adequately produce those, collagenous fibers and connective tissues to get it back together and heal effectively. A deep, wide cut without stitches is going to make a more severe scar once it's done healing. Moles. Moles tend to be an elevated, but not always, elevated, extra melanated little part. So let me draw a mole. So a mole can look like that. The darkness of them varies depending on the person. Some moles will be the exact same color as the surrounding skin. Others will be a little bit more melanated. So the difference between a mole and a freckle is a mole tends to be a very concentrated, smooth circular edge in terms of how the melanocytes in that area are producing that extra melanin, whereas a freckle is not elevated and tends to be a little bit more jagged edge and kind of random in terms of how they're produced. And freckles, the occurrence of them, has a lot to do with genetics. Some people are born with more freckles than others, and extra exposure to UV radiation from the sunlight can make the freckles more obvious as well. A birthmark tends to be as if you put a bunch of freckles together in one area. Some people are born with birthmarks on their face, on their back. I was born with a birthmark on the back of my neck or upper back, and as I grew, it stretched as my skin grew and my body grew in size, and it stretched out so thinly now you can hardly tell it's there. When I was a baby, it was a bit darker and smaller. So some birthmarks do stretch out. Others are darker and more permanent unless you were to surgically get rid of it. Melanoma and carcinoma are forms of skin cancer. Melanoma, as you can tell from the melano part, has to do with melanocytes. So remember those cells that produce melanin in the deepest parts of the epidermis. If too much radiation from the sun or some other source has damaged the DNA there, they will grow out of control. And it's usually when something like a mole starts changing in terms of the border. They usually say A, B, C, D in terms of how it develops. So if it is asymmetrical, if a mole starts looking not like a perfect circle, that could be a problem. If it starts looking kind of jagged edge on one side and nice around on the other, that's a sign that it's growing out of control and it may be home to some cancerous cells. If the border of it, this is kind of related to what I just said with the jagged edge, if the border is not a nice little circle, that's a sign that it's not doing so well. If the color is off, if one part of the mole looks darker or lighter than another part, that's a sign that part of that mole related to the melanocytes underneath might have cancerous cells. And finally, the diameter if the diameter of the mole starts changing in size, meaning it's growing actively and obviously, if any of these are true, go to a skin doctor, a dermatologist, and get it checked out. They'll take a biopsy, meaning like taking a little bit of those cells, seeing if they're cancerous, and treating melanomas early is what's going to save your life, because melanoma is the most deadly form of skin cancer. So get it taken care of. Carcinoma, not as deadly. Basal cell carcinoma is a common type. They tend to not look as dark, but once again, it is cancerous cells developing at the base of your epidermis, and that carcinoma also is from usually too much sun exposure over a period of time. And a carcinoma, will be a little section that looks like it doesn't belong there. And over time, if you also notice it's growing in size and looking darker over time, definitely get it checked out. And carcinoma is not quite as deadly, but if either of these spread to your lymphatic tissue, meaning into blood vessels or modified blood vessels that have to do with your immune response, then the cancerous cells can migrate to another vital organ, and that can result in death. Acne, it's not just in teenagers or people going through puberty. Adults can experience acne as well. And there's a misconception that it's always related to dirt or bacteria. Sometimes that has to do with acne, but there are some genetic factors and hormones that have a lot to do with acne. So some people will keep their face extremely clean on a daily basis, but they still get acne. And yes, during puberty, some of the hormonal changes can trigger acne on the face, on the back, parts of the chest even. But yeah, keeping your face and your body clean is going to minimize the chances, of acne happening. But yes, if it is related to bacteria, the way it happens is bacteria getting into one of the pores of your skin causes inflammation, causes migration of white blood cells into that area to eat up that bacteria that's been dividing. And that's how you get the little whitehead or the little pus forming. I know this is kind of disgusting, but it's also fascinating. That little pus there is actually dead white blood cells that have sacrificed their lives for you, to protect you from that bacteria. And they do recommend that you don't pop a pimple because you actually are popping a little bit of capillaries under there, and you're more likely to have a scarring effect if you do that a lot. But acne oftentimes will subside. It won't be as apparent or as widespread when someone transitions into adulthood. Sometimes when I shave, I do get little pimples, and that's because the razor has cut off some of those superficial skin cells and allowed bacteria to go into my pores a bit more easily. So keeping your face clean is going to help out a bit with acne, but there probably are genetic factors associated with it. Warts. Warts come from a virus, a papillomavirus. Now, HPV, the STD, a little bit different in terms of how it's spread, but warts in general, contact with someone else's skin who has a wart could allow the virus to hop into your skin and into your bloodstream. Warts, sometimes you only have them for a period of time. I had a wart for a while on my hand in high school. Now I don't have them. I haven't produced them for years. But what happened was this wart right here went to the dermatologist and they basically froze it off. They had a really cold material, killed the cells that had the wart virus in it, down to the root. It eventually fell off. And if the virus is still in my body, it's dormant because warts are caused by this virus, and it definitely manipulates how the skin develops in that area. Wrinkles. As someone ages, their strength and stability of collagen that they're producing is not quite as strong. It's a little bit more saggy and weak, and so that kind of less young quality of how well you're able to produce collagen is what makes wrinkles. And yes, sun, the amount of sun exposure you have can impact them. And yeah, you get like little crow's feet, and those are spots where, the wrinkles you get from just making expressions and in this area can enhance that look in terms of how the collagen is less tight. Psoriasis, eczema, and rosacea all are similar to each other, but there are some differences. With all of these, you get inflammation consistently, and these are disorders associated with the skin in terms of extra inflammation, itchiness, irritation, even a redness. Psoriasis, the sign of that is excess production of like flaky skin. One of my professors in college said that her husband had psoriasis so bad, so severely, that she would find giant flakes of skin on the couch or on the rug that her husband had shed. And he took medication to lessen the negative effects, but there is no cure. So there are creams or oral medications that can reduce the look of psoriasis. Eczema and rosacea, definitely redness, irritation. Rosacea tends to be on the face mostly, and eczema comes and goes. People will have eczema breakouts and then it will go away, but it's something that lasts. Sometimes infants will have eczema for a little while, and then as they age, they won't experience it quite as much. Finally, vitiligo. Vitiligo is the death of melanocytes in terms of them completely becoming inactive, not making melanin anymore. And of course, people think of Michael Jackson with this, but almost anyone can get it. They think there are genetic factors associated with it, but there could be environmental triggers as well. One example is I have a relative who was on a certain kind of, I believe it was cholesterol medication, and one of the potential side effects was bleaching of the skin, meaning causing at least vitiligo in part of the body. So she took this medication for months and noticed that she started losing pigment on her hands, and finally stopped when it crept down to about here. But to this day, her hands are completely bleached and the rest of her body looks tan. So she had complete destruction of melanocytes in this area. She's not going to get them back. So a medication could cause vitiligo. It's not just genetic factors, but yeah, causes bleaching of the skin. And once you're not making melanin, you're not going to have skin pigment anymore. Thanks for watching Educator.com.